Okay, guys, I think we can start the session. So today we are just continuing with the things that we have discussed in the last class. Basically, like we will be going through the programs that we can use to control turtle sim. Okay, we will see how to write a Python ROS node in order to control the turtle sim. Okay, so that is one part that we will be discussing. And then we will be jumping into the how to write custom ROS messages, custom services, yeah, those kind of stuff. Okay, and after that, if we get time, we will start with the introduction to ROS TF. Okay, so that is a plan. Okay, so let's start with the turtle sim things that we have seen yesterday. Okay. So I mentioned that the code is actually inside the package called Hello World. Okay, I actually added the script to the repository. I can able to show you that first, so you will get an idea. Just a second. So in the source code folder, you can able to see the Hello World package, learn ROS and mastering ROS demo package. So in order to compile or build this package, what you have to do is just download and copy into your ROS workspace. Okay, so in the Hello World package, you can able to see the script that we are going to discuss today. Okay, I'm just sending the link, so you can just check it. Okay. So I think we have started with the move distance.py. Then we just talked about the move turtle get pose. Okay, and then we will see move turtle board and then turtles service param. We will just go through it. Okay. So basically, if you start turtle sim, okay, you can easily start turtle sim using the following command. First, just start the ROS code and then ROS run turtle sim node. Okay, so now the turtle sim gets started. Now if you want to check the topics, you can see these are the topics, that is publishing or subscribing by turtle sim. Okay, so the command velocity is what the turtle sim subscribing, and the post is what it is publishing. So you can simply check it, those topic info command velocity. So this is what it is subscribing. Okay, it is subscribing, the turtle sim node is subscribing this topic, and this is the topic that is publishing. We can just check by this command and you can see it is publishing, the turtle sim node is publishing this topic. Okay, so last day we have worked with the move distance program, and that is not move distance, I think move turtle. Yeah, move turtle. We have seen how this program works. Okay, basically this program is a publisher like Docker, and the difference is that the topic name is different, message type is different. That's it. Okay, so basically if you check, the turtle sim node is subscribing this topic called turtle1 / command velocity. Here the turtle1 is the name of the turtle. Okay, so if I start a new turtle, okay, using ROS service, I think I have shown these thing. I think 3 session before something. So there is a thing called spawn. Okay, so if you can call this service called spawn, and then you can just give a name. Maybe I can just give a name called Lentin for a new turtle, and I can give a position for spawning. Spawning means creating a copy. Okay, so now you can able to see there is a new turtle here. Okay, new turtle here on the bottom. Okay, and then if I check the ROS topic list, you can able to see Lentin / command velocity. Okay, so it is actually automatically creating by the turtle sim simulator. Okay, so the idea is, in order to move the robot or a turtle sim, the command velocity topic is the important one. Okay, so if you are working with simulation with Gazebo or in real robot, there will be a topic like this. Okay, it may be like a plain command velocity. Okay, CMD underscore well, that is the common convention that we are using for the actual robot. Okay, so in TurtleSim, in order to understand which command velocity topic, we are just prepending the turtle name. That's it. So if you want to move the Linton turtle, what I have to do is just change this topic and then just run it. Okay, so this topic will be publishing. It is this node will be publishing to this topic. So let's see what will happen if we do that. So I can use ROS CD, which is a very useful command while working with ROS, basically for switching into the package. Okay, so you can either switch into package to check whether the nodes are there or something. Okay, also if you already know about the node name and all, then you can simply use ROS run. Okay, and then move not distance, move turtle. Then it is taking two command line arguments. One is linear velocity and then one is angular velocity. So just run it and you can see instead of the first turtle, which turtle is moving? The second turtle is moving. Okay, and I can also show you another magic, like okay, so the problem is I need to change the name. Like I can start any number of nodes actually, but for now I can just publish using the command ROS topic pub, and then I can just give linear velocity 1 and angular velocity 0.2. So there is a question from Tarun. Is it possible to give the topic name as a sys argument? Yes, we can do that. Everything can be done, everything can be customized using the command line argument. Okay, so instead of like here you can see the linear and angular velocity is getting from the command line argument. So if you want to like take the topic name, that is also possible. Okay, currently we didn't added that, so I'm just publishing this separately and then you can able to see two robots are simultaneously moving. Okay, two robots are simultaneously moving. So if you remember that project, that Iron Man project, you may be like familiar with this, like a swarm of robots is moving and then it is drawing a caricature. Okay, so the same technique, like you can move any number of robots inside the TurtleSim. Okay, just publish the command velocity. Okay, so in order to move the robot, the actual method is the command velocity, but there is a hack in TurtleSim like teleportation, meaning you can simply like put the robot in some specific places using a service called this one, teleport absolute or teleport relative. Okay, so that is not a robotic thing. Robotic thing is that the robot will move based on the velocity command. Okay, but this teleport is just for the simulation purpose. Okay, the robot will not move like if we put x, y, z value, then robot will not be teleported. Okay, it will be only moving if we give a linear and a angular velocity. Okay, so it's just for, but using this we can do some fun demos using the teleport absolute. Okay, yeah, so yeah, now I can also show you the RQT graph and you can able to see like the TurtleSim is subscribing to two topics, that is turtle1 command velocity, Linden / command velocity, and one is publishing by move turtle and one is publishing by a ROS topic node. Okay, clear, right? If you have any question, you can either comment or like you can unmute your mic and ask. Okay, so that was the Moo Turtle code. Basically, it's a publisher. Okay, so just understand the logic. Okay, imagine, I mean, if you are not comfortable with the APIs and all, even I am not I don't know all the APIs of ROS and something. So what I'm doing is I'm using some template code, and then I know the logic, how the code works. So that is only enough for working with ROS. Okay, so understand the logic, like start the node, give a name for the node, then create the publisher. Then if you want to run the publisher or the publisher at a specific rate, then use rate class. Then in a while loop you can simply publish that topic. Okay, I hope that is clear to you. And now we are coming into the move distance code. Okay, again a template code. Template code means this code is having a publisher and subscriber. Okay, publisher and a subscriber. So what happening is that this code is actually receiving three values. Okay, three values. First value is linear velocity, second value is angular velocity, and third value is the distance. Okay, distance. So if we give the linear, angular velocity and the distance to the robot, and if the x distance of the robot is the given value, or the given value that we have given as a command line argument, then the robot will stop. Okay, meaning the robot is moving, okay, maybe in a straight line or any path, and if the x value of the robot is reaching at a particular value that we have given here, then it will stop. Okay, so first I can just demo it and then I can explain it. Okay, so the intention of this code is that just to demonstrate how to get the position and how to publish at the same time. Okay, maybe I can show you that. So we have the turtle sim here, and then I'm just starting the node. Okay, so ROS run hello world, and then move turtle get pause. I think that is the code. No, it's move distance. Okay, move distance, and I'm just giving the linear velocity as 0.1. okay, angular velocity as 0, and the x value as 9 or something. Okay, 9. So when the x value of the robot reaches 9, then the robot will stop. Okay, so the current x value of the robot is 5. Okay, the robot is actually at 5. So I think that, like, the origin, I think this in origin it's 0 0. So here it's 5. Okay, 5 5 I think. So if I execute this code, then you can see it's moving in the linear. I mean, we are only providing the linear velocity. Okay, so it is gradually moving, and then you can see the position of the robot. Okay, it is 6.9 7 point something. Okay, and when it reaches 9, then you can see what happened. Okay, it will take some time. Yeah, you can see it's stopping the robot. Okay, so basically if you check the code, like the move turtle and this, actually almost similar, right? Almost similar. What is the difference that you can see? The main difference is we are adding a subscriber into the previous code, right? So we are publishing the command velocity, and the additional thing is that we are adding a subscriber. And what is the topic that we are subscribing? the topic is turtle1 pose, okay, which is the position of the robot, okay, current position. So the turtle1 pose is when it's subscribed, you have to understand the message type, okay. So the message type of this topic is you can simply get it from the ROS topic info. So this is the topic, and you can simply check ROS topic info turtle pose, and you can see the message type, okay, is turtle sim / pose. Okay, so this message type is already installed with the turtle sim. Okay, so we don't need to worry about the message type. So in order to import this message, you can use this convention, that is from turtlesim.message, okay, import pose. Okay, so if it is geometry underscore message, because the twist is from the geometry messages, so we are using geometry underscore messages, okay, that is a package name, okay, and dot message, okay, dot message import twist. Okay, so this is the usage. Okay, so we have the post message, okay, and when we subscribe this topic, we need to mention the type of message, and then whenever a post comes, this call this function. Okay, basically it's a callback. Okay, whenever a data comes in this topic called turtle1 / pose, which function will be called? Post callback. Okay, and this post is having the received data. Okay, and so currently we are getting a post data, post message, okay, which is having a type of post. So we can see what is inside this post message type. So you can simply copy paste this message type, and using ROS MSG show this type, and you can see in this post there are five values, that is x, y, theta, and linear and angular velocity. Okay, so this is what this message, received message, is having. Okay, so in order to get the x value, what you have to do is post dot x. Okay, in order to get the y value, post dot y, theta, post dot theta. Okay, so here we can see the value, the x value is accessing by post dot x. Okay, and what happening is that this callback is actually a separate thread. Okay, I think you heard about the threading in Python and C++. Threading is like, I mean, a section of the code is running along with the main code. Okay, it's so it will not block the main code. So this callback is kind of a thread, and what happening is that this value, right, the post value, we are actually updating into another variable called robot underscore x, which is actually a global variable. So in Python, if you want to mention a global variable, you can use global keyword. Okay, so global robot x, robot underscore x, and this post x value is getting updated to robot x. So once it is updated, the robot x can be accessed from anywhere. Okay, so meaning whenever this value is updating, robot x will update, and we can access the robot x from here. So what is happening is that in this loop, the twist value, the linear and angular velocity, is publishing, and when it publish, there is a if loop here. So what is it checking? If the robot x, meaning this value, okay, post dot x, greater than distance. Okay, distance is what we have given us the command line argument. If it is greater than that distance, then simply stop. Okay, then there will not be any publishing. So there is a question from Kalpesh. How does the post callback function know it has expect post as one of its argument? So the thing is, Kalpesh, in every subscriber callback, okay, every subscriber callback, like we have to mention an argument, okay, and an argument can be any type, okay. So this is Python, right? So Python does not need to specify the type of the data it is receiving, but if it is C++, we have to mention it, okay. So the pose is automatically, I mean, the Python can automatically take care of the type, okay. So the post callback, when the post callback calls, we will get the data, and that data will be the received type, okay. Then we can manipulate that data, okay. So also the post callback, the callback will have only one argument, which is the received data, okay. Is that clear, Kalpesh, or any yeah. Yeah, so the subscriber is actually mentioning like it is expecting, the subscriber is expecting data from this topic with a message type this, okay. And in the callback we will get that post, okay. So so the post will be the received data will be of type post itself, okay. So we don't need to explicitly mention, because it's in Python we don't need to, okay. And yeah, there is a question from Tejas. Will you compare CPP code for this example for this post callback? As you mentioned, there might be some type differences. Yeah, so if you take the talker, okay, talker will be the best example for publisher and subscriber, talker and listener. So if you take the talker and also the listener, you can see here in subscribe we are not mentioning the type actually on the subscriber, okay, but in the callback we are actually mentioning the type, okay. Basically you can in this usage they are actually using the pointers to access the received data, or if you want to create a copy of the received message, you can use like this, okay, like standard messages string MSG, okay. So this the received type we have to mention. So in C++ we have to mention the type in the callback, but in Python we don't need to. And also the difference between CPP and Python is that in Python subscriber we are mentioning the type of the message that is expecting, okay, from this topic, okay, but in CPP we are not mentioning the type of message, okay. We are simply subscribing it, and in the callback we are mentioning it, okay. So if there is any mismatch, like we are expecting the in this example we are expecting a string, right, and if we are getting an integer, ROS will, I mean, throw error. It will create like it will throw error like the expected message was string, but it is not matching with the received message or something like that, okay. Okay, so so in this code you can see the post value getting updated to robotext, and then in the while loop that global variable can be accessed, and it is comparing with the distance. So if this value is greater than this value, it will be simply stopping, okay. Then it will exit from the loop, the while loop will be exiting, and the robot will stop, okay. Maybe I can run it again, and then we can jump into the next code. I'm just resetting, and yeah, move distance. So you can see the robot is moving, and the robot X value is getting printed here. The X value is printing here, the information, log info. Okay, so this is like a feedback control. Like we are moving the robot with a feedback control. The feedback is the position of the robot. Okay, so if you want to move the robot for 10 meters or something like that, we can use this method. This is a very simple logic. You can use your own. Okay. Yes, so that is the move distance code. Again, a template code, we can use it for projects. And this was an intermediate code which is simply like printing the position. Oh, okay, so yeah, this is simply printing that x value. That's it. Okay, it's an intermediate code. Okay, the same code. The move distance and move turtle get pose is the same. Only difference is that there is a if statements coming. That's it. Okay. Yeah. So let me know if you have any question in the turtle sim. Like we have seen a basic publisher for the command velocity. We have seen basic subscriber. Okay. And yeah, so these are the simple programs that you can see. So Tarun is having a question, where we can find the CPP implementation of the turtle sim programs. Okay, so CPP implementation is maybe, it's available, but in this repository it's not. Maybe you can get it from the internet. Maybe I can simply show you, like twist publisher ROS C++. Maybe I can simply show you that. Let me check. This is for publishing. Yeah, I think this will be fine. Let me take some sample code. Turtle pose advertising, the same thing. Like maybe I can take this sample code and maybe I can modify. Okay, so I can show you how to create a publisher or the twist publisher for turtle sim. Okay, so we have the hello world, and I am creating a code like move turtle.cpp, and then just copy pasting the code. I'm just taking a template code. Even the talker can be the template. The same code can be taken. Let me just arrange it. Okay, so here the objective of this code is sending some random values. Okay, sending some random values to the velocity. Okay, so you can able to see the code. Like maybe I can open using the gedit. The same talker node, okay, that we have seen here. The publisher was of type string, and the topic was chatter. Here it's geometry message twist, and the topic is command velocity. Okay, and here there is a while loop for publishing. Here also there is a while loop. Okay, and here you can see we are creating a message called string. Okay, string message, that is MSG. Here we are creating a twist message called MSG. Okay, and then inside the twist message we have linear velocity and angular velocity. So in linear velocity we have x, y, z. In angular velocity also x, y, z. So for turtle sim we only need x and z. Okay, so this is a function to create random values. So that is actually assigned to x and z, and it's simply publishing it. Okay, the rate is 2, so it is publishing as 2 two heads. Okay, so I'm saving it. And what is the next step? The next step is we have to edit the CMake. Okay, we have to edit the CMake. So just go to the CMake. So if you're working with Python, then the CMake editing is not required because we are not compiling Python programs. So what I'm doing is I'm just copy pasting these two lines and then changing the source code name and then changing the executable name. Okay, so the objective is compile move turtle.cpp and create an executable called move_turtle. Okay, so let's build the package. Okay, let's build the package. Just go to learn ROS workspace. Okay, then do catkin make. Okay, let's see what is happening. So Tejas is having a question. Can we add the file name next to the execute listener.cpp move turtle? Yeah, actually, Tejas, the thing is that this line, right? This line, the listener.cpp is actually a ROS node, right? Also, the move turtle.cpp is a ROS node. Okay, so basically, we have to create separate executable for each program. Okay, but imagine you have a class or something. Okay, you have a class and the main program is main turtle.cpp and you have some class or something like move turtle. Okay, then you can include like this. Okay, so when you are creating an executable for the main program, which is move turtle, it will be also taking care of the .cpp file, which is the class file. Okay, so when you build the code, I think there is we are getting some error or something like that. Let me see what is happening. And the error is listener. Okay, I think I have made some changes earlier, so that is the reason for the listener. So when you build the workspace, guys, you can see this error, right? So you can see there is some error with the listener.cpp 7th row 32nd column. Okay, and error is also pointing base operand. Okay, because I just changed that code earlier. So this is the 7th line and 32nd. So when you get an error, be patient. Okay, don't directly try to Google or something. Just read the error. Okay, so currently like before making the changes, in the callback we have used the pointers, but currently we are using the copy of the message. So instead of the operand, we can use message.data.cstring. Okay, so that is the change. So I'm just building it. I will get back to that. Okay, let me see the packages are building or not. Yeah, currently you can see there is no error. We have built all the nodes. We have built move turtle node, and let's see how the node works. So I'm just calling the reset to reset the turtle sim, and then I'm running the move turtle node. So this is move turtle. Okay, the executable. So let's see. So you can see the turtle is like driving like a drunk driver. So basically the turtle is having random linear and angular velocity. So that's why robot is moving like this. Okay, so you can see the random velocity values is getting changed. Okay, so the implementation of the publisher, okay, the move turtle is this. Okay, and if you want a subscriber, you can simply add. So I will say the listener and talker is the template for publishing and subscribing. Okay, the same thing is applying in move turtle. Only difference is the message type and the topic name. Okay, so if you know the logic in, if like if you are working with Python or CPP, and if you know the logic, you can implement the node. Okay, and also if you are lazy like me, like to create a publisher for twist message, simply Google and you will get this code. Okay, so simply copy paste. Okay, but make sure you got the idea. Okay, so Tarun, is that clear? Is that clear? Like, it's very simple only, like just understand the logic. Okay, I didn't add any new things into this, simply a publisher. Okay, so I will be sharing this code as well. Okay, I will be sharing, so you will get an idea. Okay, okay. So I actually put a Python example because like when you start doing projects, and if it is Python, you will get some confidence. Okay, but if I am like starting with C++ for the project, I think it is slightly difficult for, I mean, to get it done. Okay, so simply start with Python, and then over the time, when you get the actual idea about how the ROS node work, we can jump into C++. Yeah, anyway, I think this example will help. Okay, I think we have just covered the turtle sim based stuff. Basically, we have discussing the publisher and subscriber thing, and one more thing is pending, which is the services. Okay, services is pending. So let me, I didn't have the code, but let me check if there is an existing code available. ROS CPP examples. Let me check. If we get it, then we can able to discuss that. Basically, like yeah, I think yeah, there are some codes for spawning the robot and all. There are some codes. Oh, this is great. This document is good. ROS turtle sim. Okay, great. And there are some tutorials. Okay, so I think we can take this code. Okay, let me check. Yeah, this code is for spawning a robot. So I'm just copy pasting, and I will explain. No problem. I'm just copy pasting the code. I'm saving to learn ROS. Hello world src, then spawn turtle dot cpp. Okay, now let me compile it. Okay, so the spawning turtle name is Leo. Okay, I think it will work. So first I will just compile it and make it work, and then I will explain. Okay, so spawn turtle. So this is source code name. So in order to compile, just take CMake, the same method. Copy paste, then just replace here. Then you can just use this keyword as the executable name. There is no, I mean, mandatory thing or something, but in order to understand correctly. Okay, done. So now what you have to do is just build the workspace using calc and make. So it's building, and then you can see the move turtle and spawn turtle is compiling, and you can see the move turtle and spawn turtle got the executable. Okay, so Tejas is having a question. We will we will have to create n number of executable if there are n files in CPP. Actually, the thing is that like imagine you have to create 10 nodes, 10 CPP nodes. Okay, then you have to write this add executable like that. Okay, even we can create some loops in CMake. Okay, we can like write for loop or something to easily compile all these things. Imagine if you have 100 nodes, right? Then there are some functions inside the CMake to make it easier. Okay, so we can write a loop, and then you can compile the 100 nodes in a single 3 lines of code. Okay, and so it's not about the CPP file. Like CPP file means if you take a code and if it is having the in main, okay, so that is actually the main code. Okay, and we will have some other library code, like using maybe classes. We will have different classes. Okay, so for that we will be adding that along with the executable, like class.cpp or something like that. But if it is a main code, okay, main node, then you have to add like this. Okay, there are some extra like CMake macros in order to automate the executable process. Okay, but for now I think we can directly use this. Okay, clear, Tejas? Right, there is no problem, right? Yeah. Okay, so just a second. Okay, so I think we have built the source code. Okay, and now I'm starting the turtle. Let me start the turtle. Okay, ROS core and turtle sim, ROS run. So make sure you are using the tab. Okay, tab will be like make everything faster, the auto completion. Okay, so now I'm running the spawning, right? So the objective of this node is that it will simply create another turtle. Okay, okay, you can see a new turtle appeared. Okay, so what was the thing that we have done to create a new turtle? We simply called a service called spawn, right? So you can call a service from command line. Okay, or you can call a service from program. Okay, so both are actually possible. Okay, the things that we are doing with the command line, everything can be done using program. Okay, so we can implement services, we can implement topics, we can implement action. All these things can be done. Okay, so let's see how the service calling happening. Okay, so this program is actually calling a service. Okay, this program is calling a service. So I actually like mentioned the service so far. So I'm just introducing a small example. So here there is a difference between topics and service usage. Okay, what happening is that in services you can see in the CPP program the ROS.h is it's the same for all the ROS CPP based node, and then in order to spawn the robot, what you have to do is we need to get the type of the service. Okay, so I can show you that, just a second. Okay, yes, so there is a service called spawn. Okay, so if you just enter ROS service, you will get a thing called ROS service info. ROS service info. And if you put your service, then you will get the type of service. Type of service. Type of service means in the ROS topic we are sending a type of message. It can be a string, it can be integer, right? It can be anything. So for service we have two things. One is request and response. Okay, so there will be a type associated with each request and response, right? So that is what service type. Okay, service type. So maybe the request may be an integer, response may be a string. A request may be nothing, maybe a empty request, maybe the response may be a integer and a string. Okay, so there are some standard service types available. If you just check standard service, there are very few services available, because in case of service we don't there is no standard services existing, because in case of topic we can send images, string, integer, but in case of service it's not like that. It can be anything. We are sending a request and we are getting a response like that. So the ROS is actually giving some standard services, which is like empty service. Empty service. So we can send an empty service request to the one node, and it after completing that service it will send an empty request, empty response. Okay, so it may be useful for switch on and switch off. And also one of the useful service standard service is set bool. I am actually using this in a lot of application. So in set bool we are actually sending a request, like it's a boolean request. So you can see the command. It is for hardware enabling and disabling. So we just sending a request like true, that is like switch on a light. Okay, so it will go as a request, and then if it is success it will be like returning as a bool value and with a string. Okay, so that is some standard services. And there is another service which is trigger. Again I'm using it, which is like again for triggering something, some actions. So here the request is empty. You are simply sending an empty request, and when the other node receive the empty request, it will be executing that request, and then it will be getting back with a boolean success and a string message. Okay, so these are some of the standard services available, and when you install TurtleSim you will get some services along with this. That is the spawn service. Okay, so if you just check the spawn service, ROS service, I think info or ROS Savi, yeah, show. Okay, so using ROS MSG you can visualize or you can view the content inside the messages, ROS message. Using ROS SRV you can visualize or you can see what is inside a service type. Okay, so in the spawn service the request is x, y, theta and the name. Okay, and the response is like this. Response is like it will be responding with a name. Okay, it will be responding with the turtle name that is already created. Okay, so if you just again call the spawn service like test1 with a new name test1, so you can able to see the response. Here we are getting the response called test1, and if you check the TurtleSim you can see a new turtle got created. Okay, so the CPP code is the ROS service call implementation. Okay, so here we are creating a node called spawn turtle, and then this is how we are calling a service. Okay, so in order to call a service, we need service client. Okay, there is a class called service client, and we have to create an object of it, and then this is mostly like a publisher, like you can just compare the publisher and a service client. Service client means who is sending the request, okay, and service server means who is executing that request. Okay, so this is a service client, and you can able to see the type of the service, name of the service. Okay, so the problem is that there are many concepts in ROS, and when you see the Python implementation and CPP implementation, you will get confused. Okay, this can happen. So idea is just understand the logic first. Okay, logic is important. If you understand the logic, then you can use any language to implement it. Okay, so in service there are two parts. One is request and one is response. So we have to create objects for request and response. Okay, response is what we are getting, request is what we are sending, and in the request you have to populate with our request data, right? So request REQ is the request object, and inside the request we have X, Y, theta name. I think we already have seen the service type. So we are populating with X value, Y value, theta value, and the name. Okay, so these are the service type. I mean, these are the data inside that service. Okay, inside the request. So you can see a line here, right? 3 hyphen. So the part above that 3 is request. Okay, this is for response. Okay, so this is a kind of division. So we have populated with the request, and then what we have to do, we have to like send this request, right? So before sending this request, we have to just check whether this service is available or not. Okay, so that is what this function wait for service. So what this function does is that it will wait for 5 seconds. Okay, up to 5 seconds. Okay, up to 5 seconds to check this service is available or not. Okay, if this service is available, then what we will do is we will simply call this service. Okay, so we have created a spawn client here, client object, and spawn client.call request and response object. Okay, so when you do this, if the request is successful, we will get a return as success. Okay, and then after this line, in the response object, what we will get as a response, we will get the name. Okay, so that is what we are getting, and we are simply printing it. Okay, so let me know if you have question in this. Okay, because I already mentioned that the topic implementation, ROS topic implementation is easier, ROS service is little harder. Okay, and ROS action is much harder. Okay, but most flexible type of communication is ROS actions. Okay, so let me know if you have any questions in this program. Just understand the logic, and if you have question, let me know. In the meantime, I will be also showing a service example. So if you just check like ROS service example ROS, you will get a simple service client and server. Okay, so Tejas is having a question. Will we learn about ROS action implementation later on this course? Yeah, I am actually discussing ROS action as well. So in the code, in the source code, you can able to see the action. Okay, so that is the next topic that we are going to discuss. After TurtleSim, we will be seeing ROS action. Okay, so while discussing ROS action, again, this is the thing, like understand the logic, because you may confuse with the APIs. Okay, so that can happen. So just understand the logic. Okay. Yes. So yes. So Tejas, we will be discussing action. Okay. So in the ROS basic tutorial, we can able to see the service and client implementation in C++ and Python. Okay. So the code is there, and maybe I can able to show you how a service and client implementation looks like. Okay. Maybe after this, maybe we can conclude. Okay. Yeah, I think after this we can conclude, and maybe next session we can start with the custom rows, messages, action, and service. Okay. So what I'm doing is I am copy pasting this code. One is server, okay, one is service node, and one is the client node. We already seen how the client node works. So now what we are doing is we are creating a server. Okay, we are creating a server which is giving a service to us. Okay, so this is a example service which is actually doing computation. Okay, if you just give two numbers as a request, it will just add up and then send it as a response. So what I'm doing is I'm just copy pasting it, and I am just adding this. Maybe can just open gedit symbol server dot cpp, copy pasting, saving. After that, gedit symbol client dot cpp. Then this is a client code, so just click here to toggle the line. Okay, so we don't need the line number. Okay, so just copy pasting and Control S, saving. Okay, and what you have to do is you have to compile it first. Okay, we can first execute it and then we can explain. So like this is a CPP code. So what you have to do is just add it in the CMake. So we have two CPP code, which is symbol server and symbol client, right? Symbol client. So now I'm just copying two section, and then the CPP is replacing here, one for the server and one for the client. Okay, and now just changing the name, symbol client. I need to change here as well. Done. Okay, so we have added. Now let me compile it. Compile or build the workspace using cat can make. So you can able to see it is compiling, and then it is actually throwing some error, like the type is not found. Yeah, I got the issue. So let's see. Yeah. So the thing is that I can. So there are some other things that we have to do. Maybe I think we can explain that in the next session, because this involves custom messages. Okay, so the problem with the services are like, in order to create a service and client, we have to create a custom service. So here in this case, in the example that we have taken, this is the message type. Okay, the message type definition is this, and it is not a standard type or something. It's a custom defined service type. Okay, so you have to create a service type. Okay, then only this program will work. Okay, so that is again somewhat I mean, it will take time. Okay, so that is what I have mentioned in the mastering ROS demo package. So you can see the custom service type here, and this is the custom service server and service client. Okay, so we need to like add this service and then we have to compile it. Okay, yeah, so there is a question from Tarun, sir, what is the difference between catkin make and catkin build? So Tarun, it's catkin, it's not catkin underscore build, it's catkin space build. Okay, so guys, I think maybe I can just clarify his doubts. So catkin make is a default command present for building the packages inside the workspace. Okay, so the problem with the catkin make is there are some problem with the catkin make. The problem is that the catkin make will not consider the dependencies inside the workspace. I mean, for example, you are creating a package called hello world. Okay, and that package is having a dependency called dependency 1 and dependency 2. Okay, so sometimes catkin make will not take that dependency in an order, because in order to build your hello world package, the dependency 1 package and dependency 2 package has to be compiled. Okay, so the catkin make will not taking care of these things properly, and there are some disadvantages in that in catkin make, but for simple application I think catkin make will be fine. So there is another thing called catkin build, which is actually taken care of all these things. Okay, but you have to install this separately. Okay, so initially catkin make will be fine, but over the time I will be like introducing the catkin build, so which is like which is much I will say an improved version of the catkin build, catkin make. So you need to install the catkin tools. Okay, then we can access the catkin space build. Okay, so instead of catkin make you can use catkin build. I think I have installed catkin. Yeah, catkin build is not installed. Maybe I can demonstrate. So in order to execute catkin build, what you have to do is you have to remove the build and devel, existing build and devel, because that is created by catkin make. And let me clear all these things. Okay, so now we only having src. Now I have to install the catkin build tools. Okay, and I'm just installing it. Just a second. Okay, so now it seems installed. Just a sec. I mean, it will take some time at the end, but it's already set. Okay. Yeah, let me wait for some second. Yes, so the catkin build system is installed, and now you can use catkin space build. So you can see the same thing like the building, but the visualization and everything will be different. But catkin build, I am actually using catkin build for my projects. So the advantage is that imagine you are building packages in Jetson Nano or Raspberry Pi. If you are building lot of packages, it will take lot of RAM. Okay, so because catkin make is actually taking, I mean, it can build multiple packages at the same time. Okay, so it will take a lot of CPU and RAM. Okay, so if the single board computer is having RAM shortage, it will maybe freeze, or like it will be reset. Okay, so we can allocate, we can say to Catkin build that only use this much of RAM for the build, okay, or only use the building, I mean one package at a time. Okay, so those things are mentioned in the Catkin tools documentation. So that is actually very good while you working with the embedded system. Okay, so like if you just check like Catkin build RAM size, something like that, you can see the usage, how to like how to put the RAM size while building. Okay, yeah, so see you can put arguments like memory limit like 95. So there are different arguments that you can put along with the Catkin build. So that will be optimized for our build purpose. Okay, so you can simply limit the RAM number of package building. So Tejas is asking, and we can target build package as well. Yeah, so like even for Catkin make we can build it separately, but here if we want to build a single package, I can use this Catkin build learn ROS. So it will be building that specific package. Okay, so like in order to remove the existing build file, you can simply delete the build and devel, and also logs you can remove. And if you use the Catkin build space the package name, okay, learn ROS, then you can see it is building that package only. Okay, so like that there are many different usages for Catkin build. Okay, so it's your choice to select the build system. Catkin build is the best. Okay, but for simple application I think Catkin make also fine. So if I'm building using Catkin make, then we will get an error because it's already built using Catkin build. Okay, so they are saying like please remove the build space or pick a different build space. Okay, so if you want to remove it like build and devel and logs, okay, then use the Catkin make. So it will be building again in Catkin make. Okay, yes, so yeah, I think that's it. So in the next next session we will be discussing the service, then action, specifically custom services and custom action. Okay, because that is somewhat complicated. Okay, so if you check the action code you can understand. Okay, this is the action server code. Okay, so you can see how complicated it is. Okay, and this is the action client code, and also this is service server code. Okay, and the thing is that if you understand the logic, then everything will be fine. Okay, but the problem with working with the services is we have to create custom services mostly. Okay, so that is having some more work to do, like in CMake specifically. So if you check the CMake, you can see like add message file, add service, add actions, then generate messages. All these things we have to add. Okay, so I think we can start with this topic in the next session. Okay, you can also check with this package. Okay, I will be adding this this learn ROS package to our repository. Okay, so I think you can also learn not only learn ROS, also the hello world. Okay, so you can just practice with this this code. Okay, so now we can have a Q&A session. So let me know if you if you have any question, because we are actually approaching to the programming part, the actual stuff in ROS. Okay, so this is not easy. You have to practice. So basically I'm giving the source code for practicing. Okay, so don't jump into big applications or something. Like just work with this basic stuff, and then create a better understanding about the communication using ROS topics, ROS service, and ROS action. Then you can slowly build up. Okay, so that is what my suggestion is. Okay, so mostly students are complaining. I mean, most of the students, learning ROS, they actually like start learning ROS from some YouTube tutorials, and I mean, most of the YouTube tutorial may not be complete. They may not be talking about each minute aspect. They will be like talking very general things. So the problem is we will assume a lot of things, and that can cause confusion. So just ask questions, guys. Like if you have any question related to the services, then the topics, then let me know, so we can just clarify your doubts and just move on. So time for questions. Any question, guys? Is it clear? Okay, I think it's clear to you, right? So if you have any question, don't hesitate. Like you can ask, maybe you can directly ask. You can just DM me, or you can just post it in the ROS answers channel. So that will be beneficial for others as well. Okay. Okay, everyone. I think we can just conclude today's session, and then for next session we will be like coming up with the service, action, custom topics, custom ROS messages, custom ROS service types, and custom ROS actions. Okay, thanks for joining, and see you next week. Okay, I will keep you posted. I will be uploading the videos, yeah, so if you have any doubts, you can ask me. Okay then, bye everyone.